Thank you, Catherine, for joining on this conversation
Thank you for
at the battery
inviting me.
show in Hong Kong here. So, can you tell me a little bit about what ProLogium does and a bit of your business?
Okay. ProLogium is making solid state battery that doesn't trigger thermal runaway, meaning no fire, no explosion. So I think it's very important for us to have this ultra safe battery in the coming future, since we need battery for literally everything in the coming future.
So, can you explain a bit for the viewers in terms of when you say solid state batteries, and today in the market you typically have the lithium ion ones. So, what's the difference? I mean, are lithium ion ones also solid state, or because you mentioned that solid state prevents hazards.
Mm.
So, can you, if
Okay.
you explain a bit?
Yes, sure. So when we call solid state, it's comparing with the liquid electrolyte used in the conventional battery today. And why we don't want a liquid anymore? That's because the liquid electrolyte is organic in nature. And when we have the very dangerous component as cathode and anode in a battery, we don't want the two electrode touch together, which triggers thermal runaway or explosion. And the liquid electrolyte is a catalyst to this reactive reaction. So we want to remove the organic ingredient inside this battery cell. But when I say solid state, that's because people is expecting solid state electrolyte will be safer. But we don't call a solid state battery just for solid state. We want a next generation battery which is truly safe, and also at the same time provide the good performance as a balanced performance index. So we need safety, we need energy density for lighter battery, and also we need a good low temperature and high temperature operation, and also a good performance during extreme environment. And not the least, latest but not least, we need a battery to have a long life. And all these cannot be achieved uh, in one single conventional battery. Because of some reason, we always trade off between these performance and safety. But now with our Gen 4 battery system with the inorganic fluidized solid state battery, we can reach all. So that would be the difference between our battery and the conventional battery.
So, when you say conventional battery, are you meaning the lithium ion ones that are available in the market today as well?
Yes, yes. So now we are saying the conventional as the liquid lithium ion batteries, and we are using different chemical systems inside the lithium battery. So we have LFP, we have NMC cathode, and sometimes you will hear that the anode is graphite or the anode comes from silicon or lithium metal. But all of these batteries are using lithium inside this battery. And conventional lithium ion battery, they are using liquid electrolyte. But we remove the liquid or the organic ingredient inside our batteries. And additionally, we are replacing the separator from polymer separator to ceramic separator, which has a good thermal stability and mechanical resistance to prevent from the direct contact between cathode and anode, which cause the thermal runaway.
So, in terms of cooling, do solid state batteries have any additional distinct advantages over conventional battery?
Yeah. I think the basic or the foundation is the safety. When you don't need to worry about the safety, you don't need that much structural materials inside the pack. And for the cooling, you need a very good thermal characteristics of the battery. And the heat dissipation of our battery will be better than the conventional one. Therefore, you don't need complex cooling system. So you can simplify the battery pack design. So you can have a further lighter and cheaper packs instead.
Right. So, in terms of your existence in Asia, how do you see the whole Asian market for your
Okay.
products?
I think Asia is considered the most advanced region for battery development. Not only China but also Korea and Japan. So we see the market here and we see the supply chain here, but we are on a different track. So some proprietary material we will be in-house developed and maybe in-house produced for a while most of the common material like a cathode and part of the anode, we will source from the market, which is abundant in Asia region. So we work with material partners across Asia for the main material that we need, while we are making the proprietary material in-house as a know-how.
Right. So, ProLogium has established a gigafactory in Dunkirk,
Mm.
right? So, I mean, what's the value chain that you are trying to create, and what are the strategic factors that led to choosing France for gigafactory?
Okay, I will answer the latest one first. I think Dunkirk is a great location after we filtered from 90 sites in Europe. So we have the evaluation metrics considering the location for logistics and also consider the ease of obtaining the electricity, stability of the electricity, and the price of the electricity. Since making a battery, we consume electricity and we need to have a stable providing of the power. And France is or Dunkirk is having the advantage over the location since we can have some material coming from Asia and there's a good a port there, a seaport there. And also we can ship our finished good to the States or to other place using the same factory facilities in Dunkirk, while we can ship the finished battery across Europe because it's in the middle of the Europe. And regarding the electricity, we have nuclear and some new energy there. So it's a good combination of clean and cheap electricity in Dunkirk.
Right. So, in terms of your market, which is your largest market? Is it for finished products? Is it Asia or is it
Uh,
the West?
Right. Our market strategy comes from in twofold. One is the vehicle or mobility, where we need to produce the battery in a closer proximity to our customer. So that's the case for EV, or even for the airplane or the eVTOL or drone that we are making. So that would be the case where we need to put our factory in Europe since our first wave of market will be located in Europe and the States. However, we do see some niche application in Asia, like robotics or the construction car, where we need a fast charging or the low or high temperature operation. So we work with Kyushu Electric to work on a solid state battery construction car where you can put the car to have a higher work payload on the site, can operate as normal condition during low temperature. The battery for niche market will be produced in Taiwan. And later, we will work with partners like Future Electric to have the backend production closer to the final destination, because the process of our battery can be divided into front end and back end, where we are stacking the battery to the volume we need and to the formation on the back end. So we can work with customer or tier one partners to have these facilities closer to the end destination. So we will focus on the core technology, which we call inlay production in Taiwan. So there will be two different strategies. Yeah.
So, in terms of growing the ecosystem for solid state batteries, how are you really working with partners across the ecosystem so that there is faster commercialization of solid state batteries?
Right. As I just mentioned earlier, for the cathode material, we are using off the shelf, but very high utilization, very aggressive cathode like NMC 955, which cannot be used in current lithium ion battery because it's too dangerous. But since we are safe enough, so we are working with cathode suppliers in China and also in Europe to qualify their material to our products so that we can have multiple supply for the main ingredient in the battery cell. And some of our partners from China, they are having their production facilities deployed in Europe as well. So we can continue our collaboration with them in their European sites. And from the anode side, we are having a special recipe of our silicon anode. We are using 100% silicon. So silicon anode will be our key material. But same thing, we can work with the partners that we already work for a long time to localize the production in Europe while we are still having the supply in Asia. And for the backend partner that I just mentioned, they are a lot of battery makers in Europe. They need more advanced technology, meaning that higher energy density, safer battery, and they don't have the technology yet today, but they can use our inlay so that they can do the final packaging of the battery with our core technology to their customer. So that will be the middle stream partners that we are working with in Europe. But for the downstream, I think for those customers needing the more advanced battery solution, we already work with them through the JDA so that we will continue to improve the performance of the battery and help them or develop the battery pack or system together with them so that they can launch their solid state battery or the next generation battery application as soon as possible. And for the upper stream, like mining, right now we are working with some partners for the closed loop recycling. Since our battery is in better position for recycling because we don't have the liquid electrolyte. So basically, you can tear apart the battery very easily so that you can separate the cathode to the black mass handling from our partner, while we can recover the separator ceramic material and solid state electrolyte in-house since it's confidential, but we can recover, meaning that we don't need some more process to recycle and redo the material. So we are recovering those material in-house. And for those silicon, we are sending it to our partners where they can regenerate the precursor of the silicon material on their sites. So basically, the percentage of the recycle part or recover part can be higher than the conventional battery that we see.
Very interesting. So, where do you see over the next 5 years the battery technology evolving?
Okay. I think we can see that more and more conventional battery maker, they are working on uh, higher energy density, but keep the certain level of safety. But they already reached the ceiling of the energy density because they cannot use the aggressive but active material, as I mentioned, like NMC 955, because it's already too dangerous for them. So I think the everybody is working towards the safe battery and to keep the energy density higher and also to have the longer life battery. So that will be something customer or consumer would like to have in the future. So we are working together towards that direction, but right now we don't see the total solution in the market yet. So we are seeing our Gen 4 battery as a good fit to fulfill all rounds of the performance requirement.
Right. So, congratulations on your winning the Women in Energy Award
Thank you.
last evening.
Thank you.
So, how do you see the role for women in energy? Particularly, I mean, energy has always been a very male dominated industry. So,
Right.
how are you seeing the role for new generation of women to come into this industry?
Right. My opinion is that in every industry, it's all about project management to reach the goal that you set. So, talking about project management, lots of tasks involves communication and stimulating the thoughts among the team members. So I think that would be something women probably can do better. And that's how I see myself in the working environment and in the team. And for motivate people, I think also that's one thing I can see as an advantage from women leader. So soft power, everybody is talking about that. It's something that we can move the team together towards the direction that we set with good communication and good spirit steering. That's how I thought about the women leaders.
Right. Thank you very much, Catherine.
Thank
It was
you.
pleasure speaking with you.
Thank you very much. Thank you.